So before I begin, I would like to briefly introduce Open RAN for those who may not be familiar with the concept. Open RAN, which stands for Open Radio Access Network, but don't worry, we will be discussing it into detail later. And it is an innovative approach to designing and building mobile networks. And it aims to make the network architecture more flexible, cost-effective, and easier to maintain, while also encouraging competition and innovation among suppliers. So in today's webinar, we will discuss several Open RAN use cases like the white box hardware, traffic steering, and the RAN sharing. Okay, RAN sharing, one of the interesting use case. And as we explore these use cases, we will discuss the unique challenges and opportunities that Open RAN presents in each scenario and how it is transforming the way we think about mobile network deployment. So we encourage you to ask questions, but I'm not sure if we can answer all questions now because we have limited time. However, we will do our best to address them during the discussion or at the end of the session. Okay. So now let's jump into our list of topics. Okay, so this is what I prepared, no? Not preferred, prepared for you. Introduction to radio access, just to have a quick overview. RAN components, okay, and radio network simulation. We will have some simulation sample so you can easily grasp, no, what is really happening in the RAN and how we can do the planning or optimization, and you can correlate it on the processes and some parameters that we will be discussing today. And then we have this RAN and OSI layer. So, and then we'll have a quiz. Okay. And then we'll delve deeper into the ORAN technical priorities. And then we have this ORAN use cases, ORAN use cases phase 2. And then we'll discuss in detail the white box hardware, what is a white box hardware, traffic steering, and RAN sharing use cases. So before we start, we have a pre-quiz or pre-test. Okay, I'll just end the poll dun sa kaninang polls, and then I'll start the pre-test for the Open RAN use cases. Okay. Okay, so those are only 10 questions just to test what you have currently, have about Open RAN. Okay, so please take that quiz. So 10 questions lang po yan. Okay, so let's start with the introduction to Open RAN. So it's just a quick review to set the stage and discuss what is the role of Open RAN in telecommunication system. Okay, so the radio access network, okay, or the RAN, is strategically placed between or in different places, okay, to provide wireless coverage to users within a specific geographic area. Like for example, in the Philippines, we are building different radio access network. So for those people who are not yet familiar what is a radio access network, in a general term, we call it cell sites. Okay. So the placement of the RAN component, such as the cell sites, is critical to ensure that the users have reliable and consistent access to the network services they need. Okay. So when they are planning or when planning the deployment of RAN or cell site, the network operators consider various factors, like for example, the population density. Because some of the questions like why the existing operators are not building cell sites all around the Philippines, no? Because there is these factors like population density, topography, okay, terrain, building density, and the traffic patterns within the coverage area. Okay, so by analyzing these factors, I'm not sure if it's working. No? Okay, so you can see the changes, no? Meron tayong binu-build na mga cell sites. Yan. So thousands of RAN elements or cell sites create seamless coverage and mobility. Okay. So like for example, in urban areas with high population density and building density, the network operators may need to deploy more cell sites. Okay. So with lower output power to have better coverage and higher capacity. While in rural areas, like for example, in North Luzon, South Luzon, parts of Visayas and Mindanao, um, with lower population density, so network operators may need to deploy fewer cell sites with higher output power and to provide coverage to larger areas. Okay. So this is an overview of a mobile network coverage. So as we build cell sites, so they are strategically placed across a geographic area. So we put the cell sites or the radio access network strategically to ensure the mobile devices within the network's coverage area can connect to the RAN and access the network services. So you can see in the photo that there are different types of mobile coverage, right? So not all cell sites have complete technology on it. So some cell sites or radio access network, it's either have 2G, 3G, 4G, or all of the technologies up to 5G. So what are the wireless telecommunication system components? So it's composed mainly by three parts. So we have the core network, okay, the radio access network, and the user terminals. And the core network is responsible for managing the overall operation of the network, including the routing traffic, okay, between different networks and providing advanced services such as voice, call, SMS or messaging, and data services. And the RAN or the radio access network, on the other hand, is responsible for providing the wireless connectivity required for mobile devices, okay, to connect to the core network and access all the services. So it includes all the network of cell sites, each of which has a base station that communicates with mobile services or devices over the airwaves. And the connection between the RAN and the core network could be on different means, like microwave or wireless, could be a fiber optic, or could be a satellite via VSAT. The user terminals, also known as, like for example, if it's 2G only, it's mobile station, but for 3G up to 5G, we call it the user equipment. These are the devices used by the end users, to connect to the radio access network. So these are typically your cell phones, your tablets, or your iPad, okay, and other mobile devices that are equipped with wireless connectivity features such as cellular, Wi-Fi, or Bluetooth. Okay, so let's focus on the radio access network. The mobile network coverage comes from RAN. So that's the reason why you see a signal on your phone. Okay, so the RAN is responsible for providing the wireless connectivity required by the mobile devices, okay, to connect to the core network. Okay, so this is the typical example of a RAN. So it includes a network of cell sites, as I mentioned, and it is the nearest, part of the network that is nearest to the subscribers and widely and strategically distributed. These are huge in numbers. There's a lot of it, and to create a seamless coverage and mobility. So, have you ever stopped to think about how your mobile device is able to connect to the internet and make calls and texts while you're on the go? So, thanks to our radio access network, that's all around you. Okay. So next time you're out and about to take a look around, so you're likely to see cell towers, okay, on top of a building, okay, like this, or alongside the road, or inside the malls, okay, or top of a mountain, provinces, or even on beach, okay. So the RAN is that enables, no, is the one that enables you to stream music or video or stay connected with friends and family, no matter where you are. Okay, so as long as merong cell site, you will have coverage. Okay, so let's move on to the evolution of mobile communications. So can you imagine a time when mobile phones didn't exist? So it's hard to believe, no? Now, but not too long ago, communication on the go was limited to radio and landline telephones. And that all changed with the introduction of 1G, okay, or the first generation mobile communications in 1980. So these early mobile phones were large and expensive, and the network coverage was limited. But despite its limitations, 1G laid the foundation for the mobile revolution that was to come. Then next came 2G, or the second generation mobile communications. Okay, so 2G was introduced in the 1990s and enabled basic voice and text messaging services. So when it was introduced in the Philippines, became the text capital of the world. No, so we had around 100 million SMS per day. So it used digital signaling and allowed for more efficient use of radio spectrum than the previous analog system. Yeah. And then after that, noong 2000, 3G came, or the third generation mobile communications. So it has faster data speeds and enabling more advanced services like the mobile internet, video calls, and multimedia messaging. And then in 2010, 4G, or the LTE, or long-term evolution, was introduced with even faster data speeds, better network capacity, and more reliable coverage. Okay, so 4G enabled yung ating mga advanced services like streaming video, online gaming, and mobile payments, and paved the way for the Internet of Things and other emerging technologies. And now we're in the era of 5G, or the fifth generation mobile communications. 5G promises to be even faster and more capable than 4G with data speeds up to 100 times. So yung mga existing operators natin, they already achieved, no, sa mga test cases nila and sa mga live deployments nila up to 1 gigabit per second. Okay, you can check that also sa mga YouTube channels nila. 5G is expected to enable new and innovative services like augmented reality, autonomous vehicles, and smart cities, and transform the way we live and work. Okay? So dito maririnig natin yung tatlong use cases, yung enhanced mobile broadband, massive machine type communications, and ultra reliable and low latency communications. Okay. And have you ever heard yung mga tinatawag nating GRAN, UTRAN, EUTRAN, and NGRAN? So these are the names, no, ng radio access network that are used in different generations of mobile communications. Like for example, in 2G, we call it the GERAN, or the GERAN. So GSM Edge RAN, or Radio Access Network, is the name of the RAN used for 2G, or the second mobile communications, generation of mobile communications. So yung telepono natin, we call it mobile station sa 2G era, no? And then yung ating mga cell sites, we call it the base station, or the BS. Sa 2G, sa 3G, we call it the UTRAN, or the UMTS Terrestrial Radio Access Network, no, for the third generation mobile communications. Yung telepono natin sa 3G, ang tawag natin is user equipment. While yung ating cell site, we call it the node B. Yan. So from base station, naging node B. And then the 4G, ang tawag natin sa radio access natin sa 4G is the EUTRAN, or the evolved Universal Terrestrial Radio Access Network. Okay. Ang tawag naman natin sa mga telepono natin is still UE, or the user equipment, and sa mga cell site natin is E-Node B. Okay? Evolved Node B. And then finally, sa 5G, we call it, actually in this example, we call it NG-RAN. But as you move along sa study ng 5G, you can learn that the 5G radio access network has a lot of names. It depends on the architecture that we will be implementing. But in this example, we will call it the G node B, okay? Or the next generation node B. Okay? And yung ating telepono, we call it still user equipment. Okay? So each generation of mobile communication has its own name, but it has the same working principle. So if you learn one technology, like for example, 2G, 3G, 4G, and 5G, as you move along, you will realize that it is in the same working principle. Okay, let's move on sa RAN components. Okay, so we have this architecture, basic architecture of 4G and 5G core network. Meron tayong RRU, okay, the remote radio unit, and then we have the BBU, or the baseband unit. So this is the traditional network. So the connection of the BBU going to the core, we call it the backhaul network, okay, or the backhaul. And then the BBU to the RRU, we call it the front haul. Okay? And then ito yung nagbubuo sa ating radio access network or the RAN. No? So let's take a look, no? Ano yung physical component niya na makikita natin sa cell site pag pumunta tayo sa site. First, there's the tower structure. Okay, so this is the physical structure that supports the radio access network components, such as yung mga antenna cables, no? Antenna and cables, and the tower structure is designed to be sturdy and stable even in high winds and extreme weather conditions like here in the Philippines. So iba-iba yung klase ng towers natin. We have these four-legged towers, we have these guide towers, we also have the monopole. Sometimes we put it on top of the building, gumagamit lang tayo ng tripods, okay? And sometimes if the building is really high and then we need to cover a road, we put it on a wall mount, no? Yan, nagwo-wall mount lang tayo. Dinidikit natin sa mga pader. Yan. Okay? So, this is the tower structure. And then there is the antenna system. Okay? So, you can see here on top there is what we call the panel antenna, high band. Like for example, this is the 1800. And there is separate antenna for 900 megahertz. Okay? So the antennas can be multi-band. So meaning in one physical form factor of the antenna, it could have multiple frequencies. But in this example, I just used separate antennas using different frequencies, just for the sake of identifying that the antennas may differ in size based on their frequency. So you can see here the antenna of 1800 megahertz is smaller than the antenna of the 900 megahertz in physical form. No? And then we have the RRU, the remote radio unit. Okay. Okay. So RRUs are also frequency specific. And there are RRUs that multi-band or dual bands. So some RRUs are functioning, in different frequencies. No? So meron tayong 1800, we also have the 900. Okay? Okay, so next there are jumper cables, okay? Used to connect the radio to the antennas, okay? And then we also have this CPRI, or the Common Public Radio Interface. It's a fiber optic cable that is connected to the baseband unit. Okay, so this baseband unit. So this is the baseband unit. The baseband unit is another critical component of radio access network. So it's responsible for processing the digital signals received from the RRU, okay, and transmitting them back to the core network. Okay, so typically nasa baba lagi yung BBU, kaya hindi nyo nakikita to. No? Most of the time na nakikita natin on site is or are the antennas and the RRUs. Okay. And BBUs are enclosed or put in a cabin or an outdoor cabinet. Yan. Which has ito yung dito yung ventilation, power supply, transmission, and backup batteries. Yan. Okay, so there's an outdoor and then there's a microwave antenna going to the core network. So this serves as our backhaul, no? Connection going to the core network. So this one. Okay. So let me just draw this. So the BBU is this one, the RRU is this, and the backhaul network is this. Okay. And the front hole is this one. Yan. Itong CPRI natin. Okay. And the antennas are just part of the antenna system. So this is the example for the outdoor. How about for the indoor, sir? So for the indoor, the concept of the indoor is something like this, no? What we want to do is distribute the signal evenly indoors. So what happened if you are using an outdoor antenna? So you will have a predictable pattern, but it's radiating, no, on a predictable pattern. But you cannot control it completely, especially for indoors. So that's why we are using indoor system. So what will happen is that instead of using this antenna, we are using a specialized antenna or special antenna. We call it the IBS or indoor antennas. No? So for example, you have a building with the ground floor and second floor. Typical, we put the equipment on a base inside the basement or sometimes on the rooftop. The equipments are the same. So we have the RRU, okay, we have the baseband unit, we have the cabinet, we have the battery unit, okay. So what happens is we replace the antenna system. Okay, so we replace it with what we call the DAS or the distributed antenna system. So as we increasingly do our activity indoors, so we need to ensure that the coverage, capacity, and quality inside the buildings are good. So what happened is that we replace it with these antennas and these passive devices. So there are directional antennas like this. You can see it actually sa mga malls, no? And then you can see also an indoor antenna. Kapag tumingala kayo sa taas ng mga ceilings ng malls, you can see that indoor antenna. That's an omnidirectional antennas. Okay? But you cannot see the RRU because the RRUs and the other equipments are typically placed inside the equipment room. Nasa basement madalas or nasa roof deck. Okay? So if you have that, so you will have coverage. Okay? So you will still have coverage in this one. Okay. So this is a typical distributed antenna system. Okay? And there are different types of this. There is what we call the picosites, okay, and that is using an active antenna instead of the passive antenna, but the principle is the same. Okay. Okay, so let's get back to the RAN components on the outdoor. So let's move to the radio unit. So this is a typical equipment of a traditional vendor, a remote radio unit. So this is an RRU. So RRU is a radio transceiver that communicates with mobile devices over the airwaves and is located remotely from the baseband processing unit. Okay, so typical, it's placed near the antenna. Okay, like this scenario. So this is our baseband, RRU, no? And this is the what we call the outdoor cabin. Okay. Next, we have the CPRI or the Common Public Radio Interface or the front hole connection. So you have the RRU and then you have the BBU. So this is the connection. We call it currently in the traditional network as CPRI. There is also a eCPRI, okay, eCPRI. But the CPRI or the CPRI enables the high-speed transmission of the data, okay, of over the fiber optic cables, allowing yung connection ng RRU going to the baseband unit, okay, to communicate with each other. So typical, this one is using a proprietary protocol. That's why you cannot use same CPRI connecting different equipment. But in Open RAN, open yung ating interface na yan. So that's why yung connection ng mga GPP hardware natin, we can connect using the open interface. Then we move sa baseband unit. Okay, so ito yung kaninang setup natin sa outdoor. Okay, and the baseband unit is nandito. Okay, so the baseband unit is responsible for processing the baseband signals and is placed in the equipment room and connected with RRU via optical fiber. So dun sa mga experienced RF engineers or optimization engineers, so this is where we activate. Like for example, if you want to activate GSM, UMTS, LTE, or even NR or 5G, And this is also the same baseband where we activate the features, the softwares, and the number of RRUs that can be connected here. Okay, so that's why when we are trying to migrate from the distributed RAN or the DRAN going to the centralized RAN, so what we do, we pull this baseband unit in a baseband hotel. Okay, so buti pa ang baseband, hotel, Ayun. Okay, so there's a baseband hotel. Yeah, so it's a location where you put all of your baseband unit and you do the configuration there. So it's easier to configure. Yes. But later on, we will discuss the different architecture of the RAN. Okay. Okay, now let's move on sa coverage simulation. Okay, so coverage simulation tools are very important and vital tools for engineers like me and for network planners to evaluate the performance of a wireless network. And this also helps them identify, bubuksan ko lang yung aking I hope hindi siya maghang. Okay. Because it's eating a lot of resources in my PC. Okay. Okay. I hope you can see the screen. Yeah. So we use this tool to evaluate the performance of wireless networks, identify like potential issues, and optimize network designs for best possible coverage and capacity. So why do I need to share this with you? Because as you can see, if we replace those equipment with like for example from traditional RAN going to the open RAN, you can see that in the world of RF, it would be almost same. RF, radio frequency is almost same. But going to the equipment to the core network, that's where the difference comes in. Okay. So in this module, I will discuss key features and capabilities of this tool and the application in various scenarios. Okay. So I will be, you can see me na pag ganong-ganon kasi nasa kabilang screen siya. Kaya I apologize for shaky head. Okay. Okay, can you see the screen ng ating tool? So this tool is a simple simulation tool. This is not like the complicated tools that the operators in the Philippines are using. Medyo mahal yun, medyo pricey yun. But this tool is good enough. Yeah, good enough to demonstrate what is a radio network simulation tool. Okay, so basically we have this GIS. Okay, so graphical use or geographic information system. Okay, so in this screen you can see yung ating map of the Philippines. Yeah, so you can choose different maps. It depends on your preference. So if you want to have a topographic map, okay, and then you want to see the different terrains, okay, so you can see the mountain range here in Mindoro, and then you can also see the Cordillera region, Sierra Madre, not Cordillera, Sierra Madre mountain areas, okay. Or you can also use the OSM, OpenStreetMap, okay, so you can see the different streets in the Philippines, okay, so you can use this one, okay. Yeah, so it depends on the preference and your objective when you're using the simulation. Okay, so let's use the Google Earth. Okay, so it's a satellite view of our country. Okay, so you can see here the Cavite city. Mhm. Okay, so what else? Aside from the map, we also have these map layers. No? So you can have this basic map layers. You can have the clutters. Yan. So the clutters are the different um, entities that are on top of the face of the earth. Like for example, if you move this one, you can see that there are open areas. Okay, you can if you see the red, these are the urban areas where the population density is concentrated. Okay, and in radio network planning, the simulation map is very critical because you are putting ₱1 million infrastructure in one location. And then if you commit a mistake, it's difficult to pull out. Okay, hindi siya halaman na itatanim mo and then kapag nagkamali ka, bubunutin mo at itatanim mo ulit. It's not like that. So we are building towers here. We are building cell sites. So operators are investing a lot in this kind of tools, no, to help them maximize and optimize the cost of building a cell site. So this just on the services side pa lang, no? Okay. So we are looking at the map. So you need to buy a software and then you need to buy a separate map. Okay, so the maps are being purchased sa mga existing map vendors, no? So meron mga map vendors na nagpo-provide niyan. So the more accurate your map is, the more expensive it is. Yeah, so mas nagmamahal siya. So nakikita niyo meron tayong tinatawag na resolution. So yung pixel size ng mapa natin, okay, will depend, no, sa ating accuracy. Like for example, this one, if I check 1 pixel, okay, from 1 to this one is equivalent to 1 to 3. So 0.01, no? 0.1 kilometer, which is 100 meter by 100 meter. So that is the accuracy of this map. And some operators invest a lot sa mapa. They buy a map as accurate as 1 meter by 1 meter. Okay, so 1 meter by 1 meter. So that's more expensive map, no? Kaya mas mahal yung tool na yun kaysa dito. Because I'm just using a simple tool. Okay, so ito yung mga clutters natin. So you can see the different buildings. Okay, okay. Yeah, so if you can see this clutter is open street, open areas in urban, okay, and then forest. Okay, so we'll try to do a simulation in Metro Manila. So you have the airport, okay. So we will put it here in the busy streets of Makati. So let's try our fate here, no? What will happen? Okay. Okay. So I'll just put the simulation, no, back to back with the. So you can see the tower here on the left side of the screen, and then the simulation map. Okay, the simulation tool. So what we will do, we will try to do a simulation. So what if we will build a cell site in this location? Okay, so let's put a cell site in this very hard to acquire site. Dasmariñas Village. Okay, so this is one of the most difficult areas, no, to build a cell site. So because this area is owned by rich people, no, here in the Philippines, and they don't want to, of course, no, it's very expensive, no, to rent a lot here. Okay, so what we will do, we will build a cell site using a 900 megahertz, right? And a cell radius of, like for example, 10 kilometers only. Okay, so this is our typical site. So what we will do, so we will choose our propagation model. So the propagation model is later, no? We will just discuss it later. Okay, so I'll just run through you do sa ating mga parameters. Okay. Okay, so what we do is we have a cell site. Okay, so we will just add one cell site. Okay, so base station, a cell site that is using a 900 megahertz. Okay, so what we will do, we'll just click and then choose a 900 megahertz. So you can see this tool has the capability of simulating a lot of technologies and corresponding frequencies. But in this example, we will use a 900 megahertz, a 3-sector site. Okay. Okay, so we'll select this and then you can see. Okay, so we will just move. Okay, so we have the base station here. Can you see the base station? Okay, so the base station is already here. Okay, so it's now in the center of our tool. Yeah, na center of our tool na, no? Okay. So we can name this as like for example, Ayora ICEP cell site. Okay. So the Asia Open ICEP cell site. So two entities merge and try to build a cell site for the Philippines. And then you can see the longitude and the latitude. So these are the coordinates. Okay. This is the exact coordinate nitong cell site natin. Okay. And then if you expand this, you can see the different sectors. Okay. So sectors mean this one, no? Sector 1, okay, sector 2, and sector 3. Okay, so these are the antenna placement. Okay, so this is where your antenna is pointing. So if you put sector 1, so you'll just copy, no? Okay, just copy this one and put it here. We'll name this as sector 1. Okay, so sector 1 is using frequency 1, like for example. And the power of the RRU, okay, the power, I'll just annotate that so you can see. So the power of the RRU is set as 20 watts or 43 dBm. Okay. And then it is using a frequency 1 and then using a radio equipment of 900. So this is where the Open Run will come in. So instead of the traditional RBS 6601, which is an old radio already, we will have an Open Run or Open RRU, no? ORU. Yeah. So instead of proprietary radio, we'll just replace it with this. But you can see in the simulation, we can only use 20 watts, no? And the power is almost the same in the RF. And then we will use a cable. Okay, so LDF 50 is a jumper cable. Okay, 1/2 jumper cable. Typical, the jumper cable would be put 2 meters. Okay, 2 meters only, and then it will automatically calculate the losses. The antenna height is this. So the antenna center line from the middle of your antenna going to the ground. So that is your antenna height. So typical, if this is a village, we can set around 30 if they will allow. Okay, initially, we will set at 30 meters. Okay, so in the planning. So this is the parameter. Okay, basic parameter that we need to consider in the simulation. Okay. And then we move on the parameter of sector 2. Okay, for the sector 2, we will name it as Ayora ICEP sector 2. Okay, ICEP sector 2. 20 watts. We are using frequency 3 to avoid interference to the neighboring sector. And then we have 2 meters jumper cable and 30 meters antenna height. So it will be the same antenna height as the sector 1. Okay. And the azimuth, I forgot the azimuth. No. Azimuth is 0 degree, meaning your antenna is pointing here. And then sector 2, your antenna is pointing 123 degrees. Okay. So if you measure from this one to this one, so this is the 120 degrees. Okay. And then after setting up the sector 2, we'll set up the sector 3. So we will name this as sector 3. Okay. And then we'll give a frequency of 5. Okay. 20 watts. Okay. 2 meters jumper cable. And then 30 meter height. Okay. And then the azimuth is 240. Okay. So from here, from your tower going to this one, this is the 240. Okay. So the design, the initial design, the one that decides that is the RF engineer or the radio network planner. Okay. So you have the power to give signal, to your friends and loved ones if you're the one responsible for building. But of course, you need to consider all. Okay. So we have this typical. So we will just use this as our template. Yan. Okay, so we will just save this as a template. No? So we'll just put it as ISEP Ayora. Sorry, Ayora ISEP. Okay, so we have this template already. Okay, so every cell site that we will build, it will copy this one. So now is the instance where we want to check the simulation, the coverage of the site. But before we click the coverage, we need to, of course, check our propagation model. Okay, so we'll just use this propagation model. The percentage is 95, 95, and yeah, so this one. So we can choose this as a default first. And then we'll add the clutter losses. Okay. Yeah. Okay, so these are the different losses that will incur if your electromagnetic energy has passed this kind of clutter. Okay, so next is we'll go to the coverage simulation. Okay, for the coverage simulation, where is it? Yeah, so area study analysis. So we want to know what would be the signal value. So we will change the legend first. So let's use a legend like this. Okay. So typical in the operator, they use blue as a better coverage. Not yellow. Okay, let's put this one. Orange and yellow. And then we have this red. And then we have the black. Okay. So it's just an indicator how strong your signal on a particular area. And then we'll change the values. Like for example, neg 75 is a full bar. Neg 75 is full bar. So you can see 4 or 5 bars in your mobile phone. Okay. Neg 75, neg 85, okay, neg 95. Neg 105 is 1 bar, 1 or 2 bars. But if you go inside your house, it might drop to 1 bar or 0 bar. Okay. Okay, and neg 125. Okay, so if you see a neg 125, meaning there's no signal at all. So it's very incidental. So if you happen to have a neg 125 signal level, simply mean wala kang signal talaga nun. Wala kang dead spot yon. Okay? So this is our simulation. Okay, so now we will do the simulation. So we will just click up to neg 125. Okay, so we can just see the range of our simulation. Okay, so now we'll have to do the simulation. Just click here. It will do the simulation. Okay, it will just calculate. So the more sites that you calculate, and the more computing power it needs. No? Yeah. Okay, so this is the GSM. Yeah. So ito yung simulation ng ating GSM 900. So only one. Only one site, ang need natin. Okay? Yan. Because it's not optimized, And then the clutter, as I mentioned, the building is not part of the map. That's why yung ating simulation, I can say that it's not as accurate as the simulation tool na ginagamit ng mga operators. Okay? Okay. So if you want to optimize this, you can check the antennas. Okay? Okay? So you can check the beam tilt. We can payuyukoy natin yung antenna natin. So we can have, like for example, 6 degrees. And then also here we have 6 degrees. And we'll also have 6 degrees. So the antenna down tilt of this antenna, we will set to 6 degrees facing to the ground. Okay, and then we'll do another simulation. Let's see the difference, magagawa niya. So yun, So merong konti lang, So it depends the ating environment. Okay? Yan. Now what we can do is that we can change the frequency. Okay, change the frequency, use like for example 2100 megahertz. Okay, 2100 megahertz. So if that's the case, if the antenna, I'll just presuppose no that the antenna is also at 2100 now. Okay, because I don't have the antenna parameter here. Okay, so I changed the frequency to 2100 megahertz. So if I just simulate it, yan. So you can see the difference no of simulation of 900 and 2100. So that's the difference between those frequencies no. So yung propagation ng 2100 is worse no, or not worse, mas malaki no yung propagation loss ng 2100 sa 900. Kaya that's why kapag yung mga frequencies of 5G na sinasabi millimeter wave, so the distance is getting shorter because of the frequency parameter. Okay, so this is one type of the simulation. So let's try to build another site. Okay, let's try to build another site. And then I will put another site here and then let's see the impact now. Okay. What happened? This one no. Dito pa yung ating site now. Okay, so this one would be ISEP A, ISEP Q, and then this one would be, papalitan lang natin ng pangalan, ISEP W. Okay, para magkaiba ng pangalan sila. And then I will move itong mga cell site natin into different places. So, for example, I will move the base station here. Okay, and then this one, I will move the base station here. Yan. So you can see now, 3 base stations no, na binuo natin dun sa area. And then if we do a simulation, you can see the impact of that simulation. Yan. So mas lumakas yung signal level no, dito sa area. Okay? And then I will create another one. I'll just, oops. I'll create another base station. Okay? Which is the Iora ISEP. Okay? And put it here. Ito na yun. Yan, no? Add base station. Iora. Tayo mag-build. Okay. Put it here. Yan, i-move na lang muna natin. Okay? Yan. So, minove natin yung isang base station. Okay. So, we do the simulation again. Tingnan natin. Okay. Yan. So, we want to see the frequency, no? Kung ano yung frequency naman. So, if you want to see the frequencies of the simulation, okay? So, when we do the simulation, okay? Okay. So, we change it to the strongest signal or the best server. So when we do this simulation, what we can see is like this. Yan. Okay. So you can see in actual, okay, there are areas that has been served by specific cell site. So this one is serving this area. Okay, this cell site, this sector is serving this area, but sometimes overlapping. This one is overlapping here. Okay, and then this cell site, this sector is serving this, and then this one is this. No. So ang tawag natin dito sa mga to, no, sa border na to, this is the handover region. Okay, so what is a handover region? No? So for example, nagda-drive tayo, no, nasa EDSA ba to? So like for example, we are driving in this road, no, on this road. And then currently, ang ating mobile phone is connected on this sector. So when we traverse on this handover area, our call will be transferred into this sector. So that's the expectation. Okay? That's the expectation. And then, kapag lilipat naman tayo from one site to another site, like for example, naglalakad tayo dito, we're walking from this region, going to this region, which is served by another cell site, okay, by another cell site. So there is also a handover area, okay. So what else we can see on this location, on this simulation? In this simulation, you can also see why some cell sites are getting congestion and some cell sites don't have. So can you identify bakit? Why there are cell sites that are congested and then why some cell sites are not congested? Because some of their sectors are covering a large number of users in this area. Like for example, in this area, this is concentrated on this user only, on these areas. However, kapag wala na tayong cell site in this area, you see, we don't have any more cell sites built on this part of the, what is this? Going to Laguna Lake. Okay. Okay. So this population, what will happen? This population will try to camp on this cell site. Okay? And then compared to this cell site, they will not camp because ang layo nila, So ito yung nakikita nilang signal, So most of them will camp on this. So what will happen? This sector of your cell site will get congestion. Okay? So what we need to do? So we need to build another site, right? You cannot build a cell site. Create a new base station. Okay. Select a template. Okay, I'll build another cell site here. And then I'll build another cell site here. Okay. And then I'll just move it. Move lang natin. Yan. Move natin dito. Yan. Yan. And then another cell site. That's why we need to build multiple cell sites, Yan. Just to address, syempre, yung ating, what do you call, congestion, sa area. And to have seamless coverage. Okay? So let me do the simulation. Now, it's more, So mas marami na tayong, what happened, What did you see? What did you observe? So mas marami na tayong cell sites or radio access network that covers this population. Okay, so previously there is only one sector covering this area, but now there are more cell sites covering this population, this populated area. Okay, so that's the reason why the operators are pushing, are asking the government to help us build cell sites, build more cell sites, because if we cannot build additional cell sites, we cannot support the capacity demand, especially if the population in a certain area or in a certain city like this is very huge. Okay? So right now, anong mangyari naman dito? What will happen? This base station, okay? This base station will get congestion, right? Look, ang laki nung kinakain niyang area, compared dito. And then din dito, So we need to build another cell site in this location. Okay? So it's just it's a series of planning and careful strategic placement of cell sites or radio access network. Okay? I hope you get some insights now on this simulation. So this is just a simple simulation to help you visualize yung nangyayari sa ating radio access network dun sa electromagnetic energy. These are the electromagnetic energy. Actually, if you just check the electromagnetic energy, it will be just like this. It will be just like this. The RF is only RF. Yeah, RF is RF. All of the RF say RF is RF. So you can just visualize the electromagnetic energy. Okay, but for you to strategically identify which sector, which cell is covering a certain area, so you need to do some changes in your simulation. Okay, so that you can identify why this sector is getting congestion. Okay, so you can see this simulation. Okay, okay. So right now, like for example, no, later babalikan natin to. We'll get back on this example. But I would like to build another cell site here. Okay, and then I will put it this one. Base station. This base station 3. Wait. I'll move this base station here in the middle. So para meron tayong concentration. Yan. Okay? Para meron tayong concentration and then simulate. Mhm. Hindi maganda yung ano niya, no? Let me just fix yung ano, no? The beam tilt. Okay. Okay. Yan. So maliit lang yung kanyang coverage. No? Let's just assume no na ito lang yung coverage niya. Okay. So there are sectors that are covering a lot and then there are sectors that are covering very small area like this. Okay. So ano ba to? Base station 3 no. Let's see no why this base station 3 is let's make it 2 meters and then 20. Let's change the parameters no. So 20 meters and then 2 meters. Naubos yung signal niya kasi. No? So 20 meters and then 2 meters. And then we'll try to simulate again using different frequencies. Okay. So that we can identify yung ating signal. And then later on, pagpunta natin yan. Okay, so I think it's much better. No? Yeah. Okay. So there are times, most of the time, we are suffering or our network is suffering in network congestion because of the traffic balancing, imbalance of traffic. Meaning some sectors have a lot of population here, and we want to put or migrate or steer the traffic, from one sector to another sector, from one site to another site, from one sector to another sector, from one cell to another cell, from one carrier to another carrier, just to balance the traffic. Okay. Why we need to balance the traffic? Just imagine you're riding on a ship or a boat. If all population concentrated on the left side of the boat, what will happen? No, it will flip, no? Mag-flip yung barko mo. Kaya we need to evenly balance our user distribution. Okay, so in each sector, in each carrier, or in each frequencies. Okay? So later, babalikan natin yan. Okay? Okay. So I hope you get an insight how the radio network simulation works. Okay? Okay, can I get a thumbs up if it's okay, if you get some insights? If you got some insights on this one? Okay. Okay. So now let's move on sa sa ating RAN and OSI. So balikan natin yung ating RAN and OSI. Okay. So the radio access network is if we map the functionalities or the layers of the radio access network in the OSI layer. OSI means Open Systems Interconnection, or the OSI model. So this is a set of concepts that describes the standardized and how computer or telecommunication system communicates, regardless of how it is built or what technology it uses. So the OSI layer composed of 7 layers, okay, so which represents each aspect of communications between each layer of the network. So we have the physical layer, the data link layer, network layer, transport, session, presentation, and application. Okay, so we'll not delve deeply on this one. No? So we'll just want to map no, nasaan yung layer ng radio access network. So if you want to use a mnemonics OSI model layer, so if you want to memorize this, the correct sequence from the physical data, so there's a mnemonic available in not in the market, no, in the industry. All people seem to need data processing. Yeah, so application, okay, presentation, session, transport, network, data, and physical. Yeah. But in the Philippines, for some foreigners who are joining this webinar, we have special mnemonics here. Our special mnemonics here is in Filipino, ang pulis sa tulay nadapa. Yan. Okay. All right. So, ang pulis sa tulay nadapa. Okay. Okay. So let's move on. Ano yung mga examples no, and functions. So these are the examples and functions of the different layers. And as I mentioned, we will not mention it. But if we map the radio access network, no, so radio access network consists of the layer 1, layer 2, and layer 3. Okay, so physical, data, and network. Okay, so if you map it, the OSI layer, so this is where the radio access network layer comes in. Okay, so like for example, in the network data, we have what we call the RRC. Data link, we have the PDCP layer, the radio link control, the medium access control layer. Okay, and the physical, we have the physical layer or the air interface. And then going back to the radio access network, where are this layer is mapped in terms of the hardware. So you have the core network, and then you have the BBU previously, right? So in the BBU, it is defined as the data link and network layer. Okay, so you have this RRC, radio resource control. Okay, you have the PDCP or the packet data convergence protocol. Okay, the radio link control, the medium access control, and the physical upper physical layer. And then the RF is the RF side. Okay, so this is where the different functions are assigned in each hardware. Now, nung dumating si 5G and the 3GPP has proposed a different RAN architecture split. It's a flexible RAN architecture split. So to support the different use cases to be implemented sa 5G. Like for example, the EMBB, URLLC, and MMTC. Okay. Okay. So let's check the RAN architecture splits. So ultimately, the choice of the radio access network will depend sa range of factors. Like for example, yung specific use of the case, yung network topology na pipiliin ng operator, the available resources, and the performance requirements. Okay. So by selecting yung correct architecture, okay, for their needs, the operators can optimize the network performance, improve efficiency, and deliver high speed, low latency, and high reliability data transfer rates required by the 5G application. So I will introduce to you the RU-CU-DU splits. Okay, RU-CU-DU splits. So the RU-CU-DU split in 5G, it refers to the separation of functions within the radio access network or the RAN architecture. Okay, so earlier, that's why we started sa basic nung construction ng radio access network from the physical ng cell site, and now we will be moving on the logical connections. Okay, so we have the core network, right? And then we have the BBU and the RU. So this is the RAN, the radio access network. Now, what happens in the 3GPP approach under the technical reference 38.801? Okay, so there was a split that was proposed by 3GPP. Okay, so the split separates the RU, central unit, and the distributed unit. Okay, so it will enable yung greater flexibility and scalability and efficiency ng deployment natin, particularly pagdating sa 5G. Okay, so yung RU will be responsible for the physical layer, yung kanina pinag-usapan natin, of the radio access network, including yung RF, yung radio frequency, yung binapabuga natin kanina simulation, yung RF. Okay, signal processing and transmission. So you can see it's the same in terms of the physical. And the CU, okay, we have the CU, the centralized unit, okay, is responsible for the control and management of the network, including yung scheduling and resource allocation. Yan. And the distributed unit is responsible for the processing of data, including the modulation, coding, and error detection, and including yung ating scheduling. Okay? So bakit natin kailangan i-split no, yung ating network functions? Para mas maging flexible and scalable yung ating deployment, specifically for 5G. Okay? Like for example, yung multiple RUs can be connected into a single DU. So marami kang radio unit, pag hiwa-hiwalay mo yung radio unit mo, connected lang sila via fiber sa DU, no? Sa distributed unit. Okay? In the next slide, you will see a different terms, additional term like the mid-hole. So since nag-split tayo ng ating mga components and functionalities, yung una is meron tayong baseband unit, di ba? Hinati natin yung baseband unit into two, the distributed unit and the centralized unit. So, the connection, no, the connection between the DU and the CU will be called mid-hole. Okay? And then this is still back hole, this is still front hole, but this one will be called mid-hole. Okay? So the back hole refers to the network connections between the core network and the RAN. Okay? So responsible yan for transporting data from the radio access network to the core network. Okay? And then the front hole, okay, refers to the network connection between the DU or between the radio equipment and the baseband processing. No? Yan. So this includes yung mga connection between the radio head or the remote unit and yung ating distributed unit. And then yung mid-hole natin, yeah, is the connection of the DU and yung ating CU. Typically, natawag natin yung F1 interface. Okay? Yeah. So ito naman yung ating latency and coverage in terms of maximum coverage between the connection within each other. Okay? And ano yung mga different 5G services na pwede natin i-implement. Okay, now we are aware, no? Pinaghiwalay na natin yung ating DU and then ating CU. So now let's map yung ating mga logical functionalities. Okay, so on the next slide, this is what will happen. Okay, so yung ating CU, this one, the centralized unit or the centralized unit, centralized unit, okay. So the SDAP, okay, okay, and the PDCP will be here, okay, Service Data Adaptation Protocol, okay, and then the RRC and the PDCP is here. So yung ating centralized unit mahahati sa dalawa. We have the user plane and the control plane. So ito yung functionality or feature na i-discuss na pagdating sa software-defined networks. So in this example muna, for the sake of simplicity, paghihiwalay natin yung signaling, or the control plane and the user plane. So the control plane is the one that controls, no, yung flow ng ating data. So this is where our data is flowing and this is the one controlling it. Okay, so magkakahiwalay yan. And then yung ating DU, okay, so distributed unit, will be placed, nandito yung ating radio link control, okay, yung MAC, so yung ating mga scheduling, okay, yung ating carrier aggregation nandyan din, and then yung higher physical layer, no, so kasama dyan yung scrambling, interference coordination, segmentation, multiplexing, and error correction. And then we have this lower level split. Yan. So andito na yung ating RU, remote unit natin. So dito, nandito yung lower physical layer split. Okay, so nandito yung physical, yung inverse fast Fourier transform, yung MIMO, beamforming, yan, and the RFE. Okay? So this what happens dun sa ating logical run disaggregation. So hinahati-hati na natin yung run natin, no, yung architecture natin. And then yung mga functionality. And then after that, we'll move sa different radio split. Okay? Different functional split, no? Option for 5G. So typical meron tayong 8 options. So meron tayong option 1, option 2, option 3, 4, 5, 6, 7, 8. So si Open Run, what they're inclined to is the 7.2x, no? Yan, 7-2x. Yan, andito. Yan. So hinahati natin yung ating architecture into different splits. So pwede nating hatiin for option 1, pwede hatiin dito yung ating functionality ng RRC, okay, is will retain sa CU, and then yung remaining will be sa DU, no? So like for example, yung 7.2x, no? Ito sa RU, and then this functionality would be on the DU if it's option 2, okay? And sa CU naman, ito yung ilalagay nating mga layers. Okay, so ito yung RU, CU, DU splits. So there's a detailed discussion dito sa deep dive into ORAN architecture in a separate course. So para mas maintindihan natin RU, CU, DU split. But for this session, what I'm trying to say is we are splitting the functionality of each entity na nilalagay natin sa physical sa physical or virtual functions natin. Okay? So like for example, the 7.2x or 7 split. So what happens here, this is an example from parallel wireless. So the core network is same as usual for the LTE network. So you have the MME, the HSS, the SGW, PGW, and the internet. And then you have this aggregator of the centralized unit. So in this example, the CU and DU is combined into the virtual BBU. Okay. So you can see here the split is being done under the high physical layer. No? Ayan. And then yung functionality ng RRU, yung lower physical layer, is embedded dito sa RRU natin, and then yung RF. So yung functionality ng higher physical, MAC, RLC, PDCP is nandito sa ating BBU. Okay, so ito yung example ng 7, split 7. And the split 7 is subdivided ba, no? So meron tayong 7.2A and 7.2B. But in this case, if we have a 7.3 naman, mas preferred yung 7.2x, no? Bakit? Because it favors yung complexity nung less complexity ng ating radio unit. Okay, mas mabilis natin siyang mas ma-manufacture compared sa 7.3. So this is an example of split 8. Okay, so you can see yung split 8 naman, what remains sa RRU is the RF. And then yung buong physical, okay, functionality, MAC, RLC, PDCP is nandito sa baseband unit. Okay? So mas mas simplified itong traffic split in terms of the circuitry. So why we are doing the splits, no? Why we are doing the splits? So there are 3 main factors, no, for the run splitting. So number 1 is a need to support a specific quality of service per offered services. That's what I'm saying, no? Yung bawat services, like for example sa 5G, meron tayong EMBB, URLLC, and massive machine type communications. So if those applications have different requirements, so our architecture must also adapt. Okay? So kailangan magbago din yung architecture natin. So that's why we need to split yung ating RAN, yung radio access network. And of course, there's a specific user density and load demand per given geographical area. So merong mga areas, no? Like for example, doon sa ginawa nating areas, there are areas na marami masyadong population, no? That we must need to provide additional capacity. So Like for example, maglalagay lang tayo ng additional RU plus yung ating CUCP, nandun din, kasama rin yan, no? Para mas mabilis yung throughput niya. So ganun yung isa sa mga applications, one of the best applications nung run-split natin. Okay? And last is the available transport network. Yan, with different performance level from the ideal to non-ideal. So yung ating mga yung ating mga functionalities, like for example here. So kinakailangan natin ng transport yan. Okay? So different requirements requires different transport. So we don't want to have one size fits all na transport, no? Kasi mahal ang transport. It costs a lot. That's why the run splitting is necessary. So if you check the run split logical overview, so this coming also from parallel wireless, okay? So the different splits, no? So from split 2, 5, 6, 7, and 8. So this is where you put the CUDU, okay? And then you have the RRU. So for example, if you go for split 2, okay? If you go for split 2, so we have this, yung ating RU is nandito, no? RLC, MAC, physical, RF, okay? So list ang ating improvement niya, performance improvement. Okay. Although ang delay niyan is nasa 1 to 10 milliseconds one way. Okay. Pero yung ating throughput is nasa 410 Mbps lang. However, if we go for split 7, okay, so ang ititira lang natin sa RRU is yung physical, lower physical, and yung RF. So we can achieve at most 2.6 gigabit per second. And it's one of the best performance, no? In terms of the split. Kaya ito yung pinipili niya, no, ni Open Run. And this is also best for 4G and 5G applications. Although meron tayong mga ideal delay of 100 microseconds. Okay. Now, if we go for option 8, since hindi komplikado yung ating mga circuitry, dito sa option 8 dahil yung circuitry natin is mostly focused, yung complexity ng circuit natin will be focused here, not on the radio. We can use the option 8 for likes of 2G and 3G. No? Hindi sila katulad ng kunyari may massive MIMO applications. Wala pa tayong ganun. So wala tayong ganun dito kaya hindi siya, it does not need, no, yung ganitong klaseng split. Yung ganitong klaseng split ng split 7. Okay, so it's recommended to have option 8 for applications like 2G and 3G, and then option 7 for 4G and 5G. Okay, ayan. So the mobile operators need the flexibility to pick and choose the different splits based on the same COTS-based hardware network. So they can configure. Now let's move on sa RAN architecture. Okay, so the evolution of radio access network. So from traditional network, so we started sa traditional network. We call it the distributed RAN. Okay, so in distributed RAN, magkasama yung ating mga BBU, radio, or RRU on site. And then we are connected by a core. And then later on, there was a proposal to go for centralized RAN or the C-RAN. Okay, so the centralized RAN, what happens, yung ating BBU as move, no, sa ating baseband pool. So ito yung tawag natin baseband hotel. Sila yung mga naka-hotel na baseband ng BBU. So the BBUs are concentrated now, no, sa isang central office. Yan. Okay? So this approach can help yung reduce costs and improve network efficiency, particularly in areas with high density of coverage requirement. Yan. So siyempre, nakakonect yung mga radio natin dito. Okay? And then later on, yung functionality ng BBU, since malaki kasi yun, malalaki yung mga BBU, nakita nyo, malalaking rack yan. There is a move that to make the BBU functionality virtualize. Okay? Virtualize. Okay? So we call it the vRAN. Yeah. So the vRAN architecture builds on the benefits of the C-RAN, okay, but adds virtualization, okay, technology to further improve yung efficiency and scalability. Previously sa C-RAN, when you want to improve, when you want to increase the capacity, you need to have a board. Okay? Pupunta ka sa site, increase mo yung board, salpa ka mo ng board for 3G, or salpa ka mo ng board for LTE, additional capacity, sasalpa ka mo physically. But when virtualized RAN came in, ang nangyari, it's just a matter of configuration. Okay, virtualization. So it's a software-defined networking. Gumamit tayo ng SDN and network function virtualization. So the vRAN can create virtual network functions that can be rapidly deployed and scale as needed. Okay, so kung kailangan natin ng additional capacity, you just add resources. Okay, on this one. Okay. Yeah, but the main difference of the virtualized network, of course, proprietary yung software. Okay, proprietary yung software with virtualized functions. Okay, and then yung ating interface is still proprietary. Okay. And then pumunta tayo sa Open RAN. So the Open RAN, okay, so hati-hati na yung ating network. Okay, so meron tayong core, meron tayong centralized unit, meron tayong distributed unit. Okay. And then ang ating functionality is a cloud native functions na. And then our equipments or hardware are general purpose hardware. And of course, yung ating mga interfaces ay open. So we can interconnect yung ating mga equipment, and then we can install the software to this equipment because it's an open source. Okay? So what is Open RAN? Okay, so ito na naman, balik na naman tayo sa Open RAN. So what is Open RAN? So Open RAN means Open Radio Access Network. So this is an industry movement, that developed disaggregated, so magkakahiwalay, no? And interoperable radio access network solutions, leveraging yung mga general purpose processor. Okay, so pag sinabi general purpose processor, so they can manufacture it on a massive scale, kaya mas mura siya kasi yung mga design yan is binibigay doon sa mga members, no? Like for example ng Oran Alliance, no? So if you want to copy this design, hardware design, you can get it, and then you can manufacture it. So mas bumibilis, no, yung manufacturing, kaya yung cost bumababa. And software defined technologies, okay, and then open interface, yan, based on industry standard. So sinusunod pa rin yung standard ni 3GPP. Okay, dito kung ano man yung mga current standards na ngayon. And then what will happen is yung mga interfaces ni Oran Alliance that is added dun sa Open RAN, it will be added, and then it will have different specifications. Okay, but later on we will have a exercise on that one. Okay. So yung mga benefits of Open RAN, alam na natin to last time, but we'll just run through this. So diversified vendors, so mas marami tayong competitive supplier environment, faster network deployment, no, due to automation and centralized radio architecture, more competitive supplier environment. Yan, so mas marami na tayong suppliers, no. Katulad na nabanggit ni Engineer Leonard kanina, no. Dati, ang kausap niya, ilan? 4. And then ngayon, nasa 20 na. No? Yeah. So, mas marami tayong mga pamimilian. New innovations model. Okay? Okay. So, first network deployment, fast network deployment. Easy to access third-party software developers. Automation. Yan. So, one of the main features ng Open RAN is the automation. Powered by machine learning or artificial intelligence. Yan. Okay. And then of course, nandito yung lower total cost of ownership or yung TCO kanina, yung total cost of ownership. And that is because of the RU, no? White box concept, yung mga COTS server natin, and then yung CI/CD, no? Continuous integration development. And then reduce time to market and time of deployment, and of course, reduce equipment maintenance costs. So, isa yung mga nakikitang benefits. Yeah. The drivers ng Open RAN is, growing network demand. Okay. Network virtualization is happening. Okay, not only in the IT industry, but also in the telecom industry. And the rise of artificial intelligence and machine learning are on the go, and big data pagdating sa telecom. And of course, yung mga 5G use cases, like yung nabanggit ko kanina, URLLC, Massive MIMO, and MMTC. Next, pupunta tayo sa deployment scenarios. Yan. So if implemented well, okay, so there's a clause. If implemented well, Open RAN technology will lower the total cost of ownership in comparison with traditional RAN. Like for example, sa Rakuten, yung kaninang, yung previously na mga nagpe-present sa atin, a Japanese company deploying an Open RAN 4G and 5G. Greenfield kasi sila, no? As mentioned by Sir Leonard kanina, meron tayong Greenfield and then meron tayong Brownfield. So it's much easier for Greenfield operators to adapt agad na yung Open RAN. So Rakuten is one of them. Reported comparative reduction of 40% sa CAPEX and 30% sa OPEX. What is CAPEX, no? CAPEX yung ibig sabihin is capital expenditure. So like for example, kung bibili ka ng sasakyan, okay? So sino dito may sasakyan? If you will buy a car, so you need to purchase, no? Siyempre yung car. Okay? So insurance, kasama insurance, okay? But your cost is not only on that amount, no? Meron ka pa tinatawag na OPEX, operational expenses. Ano 'yon? Gasolina, gasoline or diesel, and then maintenance, meron ka pang what do you call this? Papalit ka pa ng gulong every 3 years or 4 years, no? And then you will have some insurance, so it's part of the OPEX. You will have to pay your driver if you're rich. Okay. So that's part of the OPEX. So in building a wireless telecom infrastructure like that, so there's a CAPEX. So you need to buy antennas, you need to buy the equipment, you need to buy the software, you need to buy or you need to pay for the services of installation, okay, commissioning, integration, pay for the RF engineers, pay for the simulation tool. So that's part of the CAPEX. And then for the OPEX, yeah, we need to pay for the electricity, right? For the salary nung mga maintenance engineers natin. So there's a lot, no? So ang reported ni Rakuten, they have reduced a comparative reduction of 40% in CAPEX and 30% in OPEX. Yeah. So yung ating deployment will have various scenarios and will need to be assessed. So it needs assessment, no? Especially dun sa mga RAN engineers. Okay? So hindi tayo pwede basta-basta nakaisip, mag-open RAN tayo, no? Not as easy as that, especially if you are a brown field operator. Okay? Okay, so coverage extension and site densification. Yan. So papadamihin natin yung mga sites natin. Like for example, in my example last time. So we want to extend the coverage, no? Natin. So we extend the coverage. So we can put Open RAN here, okay, on the outskirt, no, anong ating mga site. But of course, what I'm saying, the operator needs, no, to study it carefully. Yan. Next is deployment of new deployments in urban and suburban solutions. Like for example, indoor. Okay. Or if the operator would like to have a system replacement, to swap out. Papalitan niya yung equipment, no, ng isang operator. So the swap out is not syempre hindi nangyayari overnight, no. So there is a planning involved. So this is where RF engineers comes in na naman. Andito na naman yung mga bidang RF engineers natin. So what will happen, like for example, no, I will just remove yung ating so I will just like for example, meron tayong buong Pilipinas, no. We cannot do a swap out immediately sa buong Pilipinas, no. So typical nagsisimula tayo sa isang portion. Yeah, and then that portion might be like for example, might be part of the Batangas area. Itong area na to, we can do initial deployment here. Or part of this one, no, Catanduanes area. So yung mga isolated na madali nating, alam niyo, mako-confine yung kung may mangyari mang hindi inaasahan. Okay? So if the swap is or the upgrade is successful, so unti-unti, no? So we move up Yeah, so depende. So, kaya if you would like to become an RF engineer, so you need to have a macro view, especially if you need to become more aware of the geographic uh, map of your country or the country that you'd like to serve, no? Like for the case of the Philippines. So, so this is one of the system upgrades and replacement. Okay, and another one is the rural coverage. Yeah. So may mga areas tayo sa rural areas na wala tayong signal. Like for example, pumunta ka ng mga ng dito no sa Catanduanes pa to, Catanduanes area. Okay? And then if there are areas that don't have any signal, so you can deploy Open RAN. Okay? Because malayo to sa existing eh. So para siya magiging island site, you know? Because one of the concerns sa concern ng mga RF and optimization sa Open RAN, just to give you a point of view no sa RF. Kasi iba-iba ng we have a different point of view sa mga engineers involved in deployment. One of the main concern is the handover region. So remember the handover region. Okay? The inter-vendor handover. So the inter-vendor handover happens like for example, okay, andito tayo ngayon. No? Okay. Like for example, ibang equipment to. Like for example, this is an equipment coming from Ayora and this equipment is coming from ISEP. So what happened here is the boundary, no, handover boundary between different vendors. So same operator, but different vendor. So that will happen in the Open RAN. If you will put an Open RAN inside. So there's a different vendor, right? So there will be a series of coordination between these vendors, these different vendors, how to assign the neighbors, how to define the neighbors, the parameters, especially kung hindi natin ma-check no, real time yung mga parameters sa network. Unless talagang huhingi ka ng parameters sa kanila and then you will put it in your system. So that's one of the concerns ng mga RF. No? Next is support of private and neutral or host network. Support for private and neutral host networks. So pwede nating i-deploy siya as a private network. Okay? For example, sa mga factories, those customers that would like to have a private network for their automations inside the factory. So pwede, we can do an Open RAN. And neutral host networks. Like for example, yung mga existing tower sharing companies that initially they are just offering towers no for different operators to share. But eventually, sabi nga ni Engineer Leonard kanina, not impossible, we can have a RAN sharing no, using Open RAN. So later, yan ang pag-usapan natin. Alright, so let's just continue. So let's move on sa ORAN technical priorities. Yan. So European operators have been actively embracing the Open RAN or the ORAN movement. No? So nakita niyo iba't ibang mga operators like Deutsche Telekom, Orange, Telefonica, Telecom Italia Mobile, and Vodafone. Okay? So they are seeking to transform their networks and drive innovation in the telecommunications industry. So yung ORAN is an initiative that aims to create, di ba, yung open, standardized interface for radio access network and then making it more flexible, cost-effective, and vendor agnostic. No? So they are focusing on technical priorities because if you just let it sa mga vendors, they will do whatever they want, right? So this one comes from the customer itself, yung mga main players no, sa Open RAN. So they want to have a focused no, technical priorities such as like for example, interoperability, network automation, slicing, scalability, security, and innovation to drive ORAN adoption and revolutionize their networks. So dito kayo mag-focus, sabi nito mga to, no? This is where we want you to focus and then produce this ecosystem. Sabi ng mga major European telcos. So what are the technical building block requirements? Okay, na hinihingi ng mga operator. No? Ito, nagkaroon sila ng Memorandum of Understanding. Yan. So mamaya bubuksan natin yung Memorandum of Understanding. So the purpose of the Memorandum of Understanding or MOU is to guide and foster the development of non-fragmented Open RAN ecosystem and vendors roadmaps. So, dapat may roadmap, okay? While ensuring yung Open RAN reaches parity and best in class, no? Versus traditional RAN solution. Ano yung mga nandyan, no? Ano yung mga nandyan? So the technical priorities document provides a list. Isang buong listahan yan. Bubuksan natin yung listahan. Laking listahan nila. And then you also want to start from that if you want to go into the details sa technical aspects ng Open RAN. So technical requirements of this that the signatories of the Open RAN MOU considers yung mga priorities. No? In terms of the time frame, the operators wish to ensure the readiness of this by the start of 2022, so last year. Okay. So nandito yung cloud o cloud infrastructure. Okay. So they want to have a Kubernetes-based o cloud platform supporting the necessary RAN software. Okay. So ito yung magiging mainstream implementation in terms of the cloud. The OCU and the ODU implemented as the containerized network function on power efficient and reliable GPP hardware, yung general purpose hardware, CPUs. Okay? Yung ORU must support yan, multi-band. Dapat maraming bands. Specifically, yung mga frequency ginagamit ng mga operator na yan. So if they are not using that frequency, don't build a remote radio unit that is not on my operating frequency. Okay, so they want to do that. Okay, both with low weight and high power efficiency. Yeah, so the RIC or the RAN intelligent controller should bring enhancement in terms of intelligence, okay, and programmability. Yung main RAN features must focus both on 4G and 5G. And both targeted yung non-standalone ni 5G and standalone architecture for single operator and RAN sharing scenario. So they are looking at the RAN sharing scenarios also, right? And of course, yung open front hole. Yeah. Open front hole IoT profiles specified in the ORAN Alliance are the key for the operators. So kasama yung automation and SMO, okay? Energy efficiency, of course, security is a global priority for the operators, requiring strict policies and features across all entities, okay? So we will have that session by next week. Okay. High availability. Yeah. Okay. So if we open this MOU, okay, this what the MOU looks like. Bubuksan natin to. Let's open it. So the MOU, if we open the MOU, it's a PDF file. This one. So, Open RAN Technical Priorities Executive Summary under the Open RAN MOU. So, andito sila Deutsche Telekom, Orange, Telefonica, Telecom Italia Mobile, and Vodafone. Ayan, so ito yung kanilang memorandum, no? Ayan, so I'll just share the link with you para lang mabasa nyo siya. Pero we have a separate file for this na naka-Excel file. Okay, so the Excel file is like this. Okay, so it's available online. You can also check it online. So you can see this is the cover page. So this is the Open RAN technical priorities. So they have the intro. So if you check the intro, they are classifying in terms of the priority level. So priority 0. So these are the must-have. So these are the mandatory. Then you have this priority 1, okay? Nice to have, no? Should support. Yan. Nice to have. So priority 0 ang gusto natin. And then we have the priority type. We have the unanimity. Okay? So meaning na unanimity, all operators have the corresponding priority. So pare-pareha sila. Unanimous decision. Kasundo sila lahat. So ito dapat ang ating unang gagawin. Okay, and the minority is 1 and 2. So these are the different scenarios. Okay, so we have a different macro distributed, macro centralized, run sharing mock-n, run sharing more run sharing more run centralized. Okay. So we have the scenario. Like for example, the scenario 1, we will not go into details. Bibigay ko na lang sa inyo yung link so that you can browse it by yourselves. You can do your own study. So scenario 1, support of ORU and ODUCU non-VRAN on-site. So ibig sabihin, ito ay priority 1 nila, no? And then majority. But they want priority 0, no? Priority 0, and all of them, unanimity, they all agreed that we want to have focus on scenario 2. Scenario 2 is ORU and virtualized DUCU on-site with open front hole. Ano yun? Ito yun. Scenario 2. Yan. So scenario 2 is this one. So radio, ang ating infra is nasa cell site. The DU and the CU is virtualized, okay, and then located on site, okay. So and then with open front hole, yeah. So these are the different macro scenarios, no, and then they have the run sharing, distributed scenarios, okay, and then centralized indoor scenarios, the one that I have shown you, the indoor setup, the outdoor small cell scenarios, okay, so a lot. So these are the different scenarios. O-Cloud, OCDU, and then ORU details are here. Okay, so we'll not discuss it into detail dahil medyo marami, and then we have limited the time. Okay, so that is the MOU, no? Yeah, between those European operators. So the next slide is just the same. So I just took a screenshot of this. Okay, so this is the Excel file, and these are the macro scenarios. Okay, and then these are the different priorities. Okay. Okay. Now we'll move sa parameters and thresholds. No, yeah. So sa parameters and thresholds, like for example, no, if you are not so immersed sa radio access network, sometimes what you can see is like this, no? When you do a signal test, a speed test, what you can just see is the download speed, the upload, the ping, the jitter, the loss. That's it. But at the back end, or the backstage, a lot of things is happening. A lot of things are happening. Okay. So what are those? So this is a typical example of a mobile phone taking a speed test. Okay, you do a download, and then you do an upload, and then what's happening in your mobile phone is this. It is monitoring a lot of parameters, okay, while you are doing the testing. Okay, so you are doing the physical parameters, okay, the layer 1 parameters. Okay, we have the different events and messages happening, different measurements. So in this case, this mobile phone is connected to a 5G non-standalone network doing a speed test. That's why the speed is reaching up to 500 Mbps. Okay, so there was a screen capture of 1 gigabit, but I was not able to include. And it is connected by NSA, non-standalone architecture, meaning this mobile is connected to 5G and LTE at the same time. Okay, and you can see the different throughput in different layer like PDCP, RLC, MAC, and physical layer. Okay, you can see it's connected into both technology, 5G and LTE, because these layers have throughput itself. No, so there's throughput in the PDCP, and there's a throughput also in the LTE. Okay. Okay. So that is a threshold. So that those are the parameters. And when we go into optimization, just like tweaking a parameters or playing around with the parameters, or having a good set of tuned parameters to have your network perform better. Okay, so you need to identify those some of the parameters. Like for example, if we are talking about 5G, okay, so we have what we call this basic parameters like the threshold, okay, the hysteresis, and the time to trigger. Okay, just imagine, no? Just imagine you are located in this location, in this area, no? And then one time, you want to move, you know, in one area. And then in this area, it happens to have a 5G coverage, no? So there must be an event that should be triggered so that the system will ask your mobile phone to, hey, add the 5G carrier in your system. Okay, so there is a parameter that being followed. Okay, so we have this what we call the SSRSRP. This is signal level. How high is your signal level? How much or what is the magnitude of the signal level of 5G that you are measuring? Okay, and then not only not only the threshold of the signal level, there should also be a hysteresis. There's a margin. Now there's a margin, like for example, it should be 3 dB higher or 4 dB higher and a certain amount of time. Okay, like for example, neg 75 dBm after 10 seconds, you will go to 5G. If the signal level is consistent within 10 seconds, okay, and then with this hysteresis level, with this margin, you can add the 5G secondary carrier. So these are some of the parameters that we are tweaking. And then we are also doing this some of these parameters to shift the traffic, no, from one cell to another cell. Like for example, hey, are you an LTE 2100 megahertz? Don't go into this sector because this sector we prioritize only the L900 or the low band. Okay, so there are parameters like that in the network. So not all the time you can come in one site, no. So there is a restriction. So there are special rules in the network that is set by the radio network optimization engineer. Now we go to the ORAN use cases. For the ORAN use cases, I hope we still have time. Okay, we still have time. For the ORAN use cases, so I will introduce the ORAN Alliance. The ORAN Alliance, which was formed in February 2018, with the goal of promoting open and intelligent RAN. So this is the second organization driving the open RAN movement. So it is was created by merging of the two organizations. So the first organization was TIP, Telecom Info Project, now founded by Facebook or Meta. So this ORAN Alliance is created by merging of two organizations, China Mobile and other mainly Chinese vendors. They call themselves a CRAN Alliance, and the entity Docomo and other mainly American vendors like the XRAN. So they combined to form this ORAN Alliance. So the founding members of the ORAN Alliance is AT&T, China Mobile, Deutsche Telekom, NTT Docomo, and Orange. So the ORAN Alliance is a group of telecom companies that aim to improve the performance and openness of their networks. So they call for the more intelligence in the network through information collection for the virtualized network elements like artificial intelligence, machine learning, can be applied for the collection of information. So this is the website of ORAN Alliance. Okay, so I'll just give you the link. Okay, so ito yung link ng ORAN Alliance. So you can just check sa inyong mga PC if you'd like. Okay, but to share you this one, so ito yung ORAN Alliance. So you will learn a lot, no? Dito sa ORAN Alliance lang. It's rich information and first-hand data. No, specifically if you're looking for specifications, if you're looking for the use cases, if you're looking more about the membership, you want to become a member, if you want to learn more about the different work groups, different specifications, technical groups. Remember Dr. Ian Wong, so there is a group, like for example, he's part of one group this is this one, testing and integration focus group. Yeah, so one of our speaker, no, he's one of the co-chair of this. Okay, so if you go to this Oran Alliance, you will learn a lot. Okay, you will learn a lot, but you just need time, no, to learn more from this one. So it's rich information, wealthy of data, and so you can see here the specifications. If you want to review the specifications, the resources, the software, testing and integration, the plug fest. Okay, so like for example, if you go for a plug fest, just click the plug fest, and then you can see the different plug fest that will happen, or that has happened, okay, previously. Okay, and one of the interesting here is the virtual exhibition. Okay, so the virtual exhibition is just like going on an on-site exhibition, no? You go to a virtual exhibition like this, and then you just click, okay, and then you can see if what topic you want to learn. Yeah, so you will learn a lot, no, here in Oran Alliance website. Okay, so I encourage you to browse this internet in this website. Okay. Okay, so let's move on sa ano, sa next slide natin so we can maximize the time. Yeah, so benefits of Open RAN. So Open RAN can reduce network capex and opex, okay, and then can improve network efficiency and performance through virtualization, okay, and can import new capability with great agility, yeah, through the power of virtualization. This one is machine learning and artificial intelligence. Now, if you look at the architecture of the ORAN or the Open RAN technical work group, so you have this SMO, okay, and then you have the RAN intelligent controller, you have this CU, the DU, okay, the ODU and the ORU, okay, and then in the SMO, there's a lot of functionality there. Meron tayong design, inventory, policy, configuration, so different functions, no, involved sa SMO. And also sa RAN intelligent controller where the X apps are located, but not only the X app, there is also the radio connection management, the mobility management, QoS, interference, and trained model. Okay, so let's have define each entity in the ORAN architecture. OCloud, so this is a computing platform comprising of the physical infra nodes to host the ORAN, okay, functions. It supports yung software components and then yung mga manu functions nandiyan sa OCloud. We have this ORU, the logical node hosting, low physical layer, no, yung lower physical layer natin. Nandiyan yung fast Fourier transform, fratch, extraction, RF-based low-level split. Low layer split. No? Yan. And then yung ODU natin, it is the one that hosts yung RLC, MAC, and higher physical layer, low level split. And then yung OCU natin is divided into two, control plane and the user plane. Okay, so sa user plane, nandito si SDAP and PDCP. Sa control plane, si RRC and PDCP. And then nandito si RIC, no? Sa near real-time RIC. So meron tayong dalawang RIC, no? Si near real-time RIC, less than 1 second yung mga feedback loop niyan. And then si non-real-time RIC, more than 1 second. So mamaya makikita nyo bakit gano'ng katagal, no? So logical node enabling near real-time RIC, okay? So may include yung artificial intelligence and machine learning. And nandito yung mga X-app. Yan. So X-app designed to run on a near real-time RIC. So it's independent in a near real-time RIC. Like for example, meron tayong X-app for traffic steering, may X-app tayo for quality of experience. So those X-app perform a specific function, no? Para mag-steer lang siya ng ano, para siyang feature. Kung familiar kayo sa feature ng ano ng network. But this time it's an application. No, meron siya sariling isip. Okay. Okay. And then we have the non-real-time rig. Okay, so it control optimization of the run elements, okay, and resources. And then we have the R-apps supporting the orchestration sa SMO and the R-apps, no, independent. Para siyang XApp pero si R-app is nasa non-real-time rig. Okay, ayan. So ito yung basic functionalities. Ito is nasa nakano rin to, no? We will discuss this into detail sa deep dive into ORAN architecture. Yan. So meron tayong separate session dyan. Okay, so puntahan natin yung mga interconnections. Ayan. So this is a simplified interconnection of the ORAN architecture. Okay, so before we understand the use cases, we need to understand first the ORAN architecture and how it is working. Okay? Okay. So, si SMO, okay? So si service management and orchestration, okay? Ginagawa niya is siya yung nagma-manage, no, on the entire system ng RAN, no. So nandiyan yung mga R-apps niya. And then the SMO is connected via O1 interface. Yan. Meron siyang connection kay near real-time rig. There is it has a connection sa OE-node B if it's LTE, OCU-CP, okay, and OCU-UP and ORU. So ang tawag natin doon is I don't know, O1, no? Yeah, O1 interface. Okay? And then meron siyang connection sa cloud via O2. Okay? And then yung near real-time rig is connected kay SMO, yung non-real-time rig via A1 interface. And then after that, si near real-time rig, okay, ang ginagawa niya is connecting to the OCU-CP and ODU. Yan. Okay? And then si OCU connected kay ODU via F1 and then F1U and then itong OCU is via E1. Okay, so you can see yung mga blue font na mga interfaces. These are new interfaces introduced in the Open RAN. However, yung mga red, yung blue pala, no, para sa sa 3GPP. And the red ones are the one introduced in the Open RAN. Okay? So meaning itong E1, F1, NGC, X2, these are existing interfaces defined in the 3GPP standard. Okay? So tanong niyo, sir, saan nakakonekta yung natin, yung ating network? Nasaan yung core network natin? Nandito. Yung OCU-CP, OCU-UP, di ba ito yung BBU dati? So dito yung nakakonect. Ito yung 5G core network. Ito naman si LTE EPC. Okay? Or pwedeng X2, papunta sa kabilang E-node B, or papunta sa kabilang G-node B via XN. Okay? So nandito siya. So what will happen if the near real-time rig SMO has gone, nawala, nasira, has been destroyed? What will happen to the network? Will it still work? Of course, because meron pa rin tayong connection kay core network. Okay? So mangyari na lang, yung intelligence ng network natin will be diminished. No? Kasi ito yung ating intelligence. The intelligence embedded sa network is coming from this two. Diba? We move sa ating ORAN use cases. Ayan. So ito muna, no? Ito yung pinaka-connection niya. So ito yung ating near real-time rig. So this coming from parallel wireless. So the near real-time rig, the OCU, so this is connected sa core network natin. And then yung core network will have a connection to the SMO. Okay? And the SMO has also an external system providing yung mga enrichment data, no, that helps the machine learning or the artificial intelligence to create a new policy, no, na ibababa niya kay near real-time rig. So ang nangyayari is imagine this entire architecture, entire complex architecture. The ORAN architecture is like an orchestra, no? An orchestra. Okay, so the SMO is the one writing the notes. No, the SMO is the one writing the notes. He's the composer of the musical notes of the symphony. Okay, that's the SMO. The near real-time rig is the conductor. The one telling the violinist, no, to, hey, make it louder. You make it softer. Yeah. And the OCU-CP, OCU, ODU, ORU these are the musicians. No? So if you're handling a violin, so you are getting the instruction from the near real-time rig. No? Yan. So, ganun ang ginagawa nila. No? So, si SMO, siya yung composer ng symphony, ng music, and then ibibigay niya yan kay near real-time rig. So, ito yung ating mga, ano, no? Ito yung ating, ano ba tawag doon? Music, no? Ito yung ating, hindi ako familiar doon sa, ano, no? Sa script natin. Ayan, sa script, no? Ayan. Sa symphony, ito. And then the conductor will instruct, no, yung mga musicians natin. Okay, so these are the musicians. So they would try to check if, okay, so this set of musicians first para yung ating traffic is mag-balance. Okay, next, ito naman. So para mas magkaroon tayo ng magandang symphony. Okay, so imagine this as a orchestra. Yeah. Okay. Okay, musical sheets. Yeah, so thank you, Sir Benjamin. Yeah. Okay, so now let's take a look, ano, yung mga ORAN key use cases. No? So there are two phases actually, no, sa ORAN use cases proposed by the Open RAN ORAN Alliance. No? So we have the phase 1 and the phase 2. Under the phase 1, this is the most of the cases are about the things that are standard, meaning like white box hardware, okay, traffic steering, quality of service or quality of experience, and massive MIMO. Yeah, so these are very important because they relate to most of the situation that most operators must handle. So ibig sabihin, ginagawa na ito ng mga operator ngayon currently. Yung paggamit ng, of course, ng mga hardware. Okay, so papalitan lang nila yung from a low-cost RAN white box hardware. And then the traffic steering is the load balancing technique that we are currently doing in the network. Okay, the load balancing, no? Binabalance natin yung net load natin. Quality of experience, massive MIMO, no? So you already heard the massive MIMO applications. Currently, we are implementing it in our network. And quality of service-based network. And then we have the phase 2, the RAN sharing, okay? The RAN slice, service level agreement assurance, the content-based dynamic handover, okay, management for V2X. So these are the automated vehicle, no? And flight path-based dynamic unmanned aerial vehicle resource allocation. So you're flying a drone, and then your drone has a specific flight path, no, flight plan, and then para hindi maputol yung connection ng drone mo, and then it could sustain yung kanyang flight. So every cell site na madaanan niya should reserve a resource for them, right? Kasi otherwise magko-congestion, tapos pagpasok ng drone mo, wala ka, no? Mag-drop yung call mo. So, kaya importante yan. And radio resource allocation for UAV applications. Okay? So, in these use cases, in this session, we will discuss 3. The white box hardware design, the traffic steering, and the and the RAN sharing. Yeah. Okay. So let's start with the white box design. So white box hardware. So meaning it will be based, no, on ORAN's ORAN specified open front hole interface. So the split option is 7.2x currently supported. But the split option 6 and 8 are being considered as future study items. No? Yeah. So it tries to carry out yung open ODU software, okay, protocol function, and finally realizes yung open source and openness. Yeah. So it's just like a typical example is gagamit tayo ng open hardware, GPP hardware. Okay. Okay, so ORU. So ang focus ito is yung ODU, ORU, and yung front hole gateway. What is the front hole gateway, sir? So yung front hole gateway, dito natin pinagsasama-sama, we aggregate all the RRU here connecting to the ODU. Typical example is like this. So the best example, this coming from Lion's technology. Okay. So this is your BBU, this is your front hall gateway per cell. So sometimes you have to spread, no, yung RF, electromagnetic energy distribution. So kinakailangan kasama yan dito. So that's the function of the front hall gateway. Typical example, another typical example is like this. Your BBU is here. Okay, the front hall gateway is located here as well. So to distribute your radio unit. Okay, so your radio unit might be located on the other side of the building. Okay, other side of the dam. Okay, so just to have a continuous coverage. Okay. For local area, your front hall gateway also is the aggregator to distribute the different areas located in each different houses. And ganoon din sa indoor. No? Yeah, so from each location, in each floor, or each level. Yeah. Okay, so yun yung gamit ng ating white box hardware. So mas mura siya dahil you can generate yung reference design and then give it to the members of the Oran Alliance so that they can manufacture. Okay? Not like yung mga traditional natin that if you want to order a specific BBU, so they need to manufacture it and then we need to get it to a certain manufacturing company, entity. So matagal yung manufacturing minsan inaabot ng months. Okay? So that's the white box hardware design. And then we move to the traffic steering. Yeah, traffic steering. So what is traffic steering? No? So traffic steering is an evolution of mobile load balancing used to achieve optimal traffic distribution based on the desired objectives. Okay, yeah. So you have two cell sites, okay? Meron kang dalawang cell sites, you have to run. So this mobile user is served by the cell site. So they want, so dikit-dikit di ba? Like for example, yung ating signal kanina. Ayan. So if we go for a signal level only, ayan. If you go for signal level only, no, so there are areas that have been served, no, by almost both cell. Yeah, so hindi mo lang kung nasan ka. No? So sa traffic steering, sometimes the user goes into the cell, and then sometimes goes into the sector. Okay, but we want to control it. No? We want to have a control. Okay. So in this example, the current challenges is that the traffic steering mechanism uses the radio condition. Okay, so remember the radio condition that we are trying to explain earlier like this. So there is a radio condition that we want to achieve first before we decide on something to execute, to be executed, right? So there's a signal level, how long would it be on that signal level, and what is the difference in my margin or threshold. So I can commit to that certain cell. Okay. So that is the existing, that is the current mechanism right now. So radio conditions of the cell by treating all UEs in the same way with the average values, like for example, yung signal power. Okay? And it is limited to adjusting the cell reselection and handover parameters and cell priorities. Okay? So priority 1, L900, priority 2, L700, priority 3, L1800, like that. Okay? So the traffic steering specifies how to steer. No? Paano mo palilipatin yung yung traffic mo, no? In the mobile network case, no? To what cell or base station the user is connected. Makokontrol natin yan. It may be more general. So if we have multiple radio access technologies, no? Like for example, 4G or 5G, saan siya pupunta? So it's a decision matrix, no? Saan siya pupunta? 4G or 5G? Next, which cell? Cell 1, cell 2, cell 3. Next, in cell 1, there is carrier 1, carrier 2, carrier 3. So which carrier? So saan siya pupunta? So after we locked in that carrier, are we going to dual connectivity or not? Okay. But hey, what services are you using? Currently using? Is it voice only or data? So there's a lot of decision, no, or parameters involved before you connect to a certain cell. Okay. Okay. So once we decide which cells and base station the U is connected, okay, there may be different, no? So sabi ko nga, it's either voice or data yung kanila magiging services. So anong problem dyan? What's the problem with this? The problem is that the typical traffic steering treat all users in the same way. And then they take average values of the signal power. And they also typically limited to cell reselection lang, no? And handover parameters, pinakita ko kanina. And updates based on which the U is moved between cells, no? Kung bakit sila lilipat. So those schemes don't take into account yan. That the specific user is like, for example, V2X siya. And it might not be switched to another cell, no? At the same time, with the nomadic MBB user. So magkaiba sila, magkaiba yung services nila. V2X yung isa MBB naman, no? So it might make sense, no, to change the cell, no, of V2X UE, no, kailangan niya magpalit agad than yung MBB, no. Pwede ka lang mag-stay ka kasi naglalakad ka lang naman, no? So this is specifically a challenge, no, pagdating sa 5G. So kapag ka ang network natin, tinatawag natin heterogeneous, no? So ang dami na natin, we have a lot of type of network. We have a small cell, we have a macro cell, we have an indoor, we have an SA, we have an NSA, no? We have a dual connectivity. So it's a lot for an engineer to handle the parameters, right? For an engineer to handle that parameter. Okay? So therefore, in such like the HETnet or the traffic steering is very complicated, and at the same is very important to properly assign connections, no, to cell to utilize the resources efficiently. So kailangan maayos yung ating pagpapatakbo sa network. And sometimes it's too much for an RF engineer or optimization engineer to handle those kinds of complexity. It's much better if there is an entity, right, that is intelligent enough to do it for you, right? And that where the RAN intelligent controller comes in, okay, powered by artificial intelligence and machine learning. Okay, so the RAN intelligent controller will control the adoption of diverse scenarios, okay, and objectives. And the non-real-time rate, okay, located at the SMO, and the near real-time rate control the traffic steering strategies through the artificial intelligence machine learning data collected from the OCU and the ODU. Okay, so what happened kapag mag-steer tayo ng traffic? So this is what happens, no? So meron kang SMO, okay, so service management and orchestration function. So it defines, no? Siya yung nagsusulat, no, ng musical sheets, no? Siya yung nagsusulat, lahat, all voice users will go into this cell. All MBB users will go into this cell, or all voice users will prioritize this cell. Okay, all MBB users will prioritize this cell. So those are the policies, no, to guide the behavior of the traffic steering X up in the near real-time rate. So it also performs statistical analysis to provide enrichment information, no? Yeah. And communicates the policies and enrichment information, no, down to the non-real-time rate. And take note, no, for the SMO or the non-real-time rate to be able to learn as much as possible sa status ng network, it needs data. You need to feed it with data like the typical artificial intelligence, no? Okay? Okay? So it needs to be fed, no? Coming from the E2 nodes. So what are the E2 nodes? Ito yung ODU, OCU natin. Okay? ORU. Okay, so yan. So, ginagamit niya yung mga information coming from this to train the machine learning. Okay? And then it will send down the A1 policy and the A1 enrichment information. Okay? Ano pa yung mga other informations in the network? Yan. Okay? Dadalhin niya yan kay near real-time rate. Okay? And the near real-time rate will get the musical sheets, and then the near real-time rate is the conductor, no, in the orchestra. And then it will interpret and enforce the policies. Okay? It uses enrichment information like optimized to control the functions. Okay? The RF fingerprints coming from the enrichment information, and it will send the control messages to the E2 nodes, no, to execute the action. Okay. Okay. Tell to this DU to add resources and then give it to this UE, no, to that certain subscriber. So that's what's happening sa traffic steering. Yan. So if you will go deeper, so what's really happening on this one? So there is a flow diagram with the policy. Yan. So it's very detailed lang eh. But the goal is to drive the traffic management in RAN in accordance with the defined intents and policies and configuration. So the SMO, no? So it starts, no? So it of course it is collecting information from the E2 nodes, okay, and then training the ML, the machine learning or the artificial intelligence, okay, and then bababa niya yan kay non-real-time rate. Ibibigay niya kay non-real-time rate for evaluation and monitoring. And then later on, it will go down sa kay near real-time rate. Okay? Hindi masyado maliit na. Okay? And then, the policy will be coming from non-real-time rate, near real-time rate going to the E2 nodes. And the E2 nodes will still report, no? And then, once the objective is met, no? So the SMO will tell if we need to delete or to hold this instruction or not. Yeah. So this is how the traffic steering use case is being done. Okay. Next is the run sharing. Okay, for the run sharing, so run sharing is envisioned as an efficient and sustainable way to reduce, no, network deployment cost while increasing network capacity and coverage. Yeah. The open and multi-vendor nature of the ORAN architecture can accelerate this induction and development of RAN sharing solutions by enhancing the development and configuration of virtual RAN network. Okay, so what are the different types of site sharing models? So we have the site sharing, like the civil infrastructure and the backhaul. So it's something like tower sharing. Okay, tower sharing. Okay, and then we have the passive sharing. So we share the RF path, like for example, we share the antennas. And then we have the active sharing, the MOC-N and the MORAN. So later on, we'll discuss it into detail. And the gateway core network. Okay, so they can share the core network. Okay. So the major driver of network sharing continues to be the potential for cost savings. So instead of building another cell site, why don't we just share with the existing infrastructure present in that area? So the site sharing model, like for example, the tower sharing, just like this. So the entities or the operators share a specific space, no, on a tower or a facility. Okay, so there is what we call the vertical space or the window space. Typically, it's a 5 meter by 5 meter. Okay, so if you exceed the 5 meter by 5 meter, you need to pay additional. So just one of the typical model, no, dyan sa tower sharing. And then we have the site sharing model of the multi-band combining. So you have a different radio, and then you want to combine or you want to share one antenna. So you just need a combiner. Okay, as long as syempre yung specifications ng antenna and yung combiner would be the same as the specification or frequencies ng mga operator. So this is the multi-band combining. Next is the multi-operator RAN, the site sharing model, the active sharing. The multi-operator RAN and the multi-operator core network. So multi-operator RAN, this is what we call the MORAN. MORAN. Okay? This one is MOCN, the multi-operator core network. So what's the main difference, no? Nitong dalawang to. So later on we'll discuss into detail. Okay? So the difference is for MOCN, okay, it's a multi-operator core network. So you have two operators. In this example, we have two operators. Operator A, operator B. Operator A have a separate core network. Operator B a separate core network. So the main principle of the RAN sharing is this. Share the RAN, split the core. No? Share the RAN, separate core. Like that. So in the MOCN, what is happening is that, like for example, no, we have one entity here. We have one tower here. Okay, we have one tower, and this tower is owned by operator A. Operator A. Okay, operator A. And then operator B wants to have signal also. Wants to have a coverage, but would like to save cost. What will happen is that in the MOCN, they will share the frequency, the radio, and the transmission. And then it will be separated by a core. So the frequency of operator A will be shared to operator B. Okay? Are you getting my point? So this is MOCN. And the call will be separated into each operator. So that's the simplified explanation for the MOCN. And what is MORAN? For MORAN, the tower is owned by operator A again, but they will not share the frequency. The frequency will be used is owned by operator B, and another frequency will be used by operator A. What they will share is the radio equipment infrastructure. As long as there is an excess of power on the remote radio unit, so that the operator A can use this part of the radio and operator B can still use this part of the radio. And then they will propagate different frequencies in this radio. One frequency from operator A and then one frequency for operator B. So separate frequencies sila. That is MORAN. If it's same frequency, only one frequency, that is MOCN. Okay? Only one frequency. Frequency of the host operator. In the MORAN, the radio equipment only, but separate frequency. Okay? Operator A and B. So, paano gagana dito ang Open RAN? Okay? So, what should we do sa Open RAN? So, we need to have a virtualized network in place. Okay? So, what we will do, we need to have a setup of Open RAN setup in our network. Like, for example, we have an open hardware already. Okay? And then our functionalities are already virtualized. We have a SMO, and then we have a real-time rig, a non-real-time rig. Okay? So what happens is like this. There is an Open RAN from operator A and Open RAN for operator B. Each operator will have separate SMO. Okay? Separate SMO. SMOA, SMOB. Okay, and each has a separate NRT or near real-time rate, a non-real-time rate. Okay, same goes with the non-real-time rate. What will happen? And then the computing resources will be shared. So meaning it's virtualized already. You can define your own OCU, OCP in the hardware, no, nung vendor na to, or in this shared computing resources. So what will happen? The OCU CP or the centralized unit or centralized unit control plane and the user plane will be defined, okay, via VNF, virtualized network function, in the operator A's infrastructure. And the ODU functionality also is virtualized, can be defined in the other operators infrastructure. And then you can control it, okay? So you can have an E2 connections, okay, remote connections, so that the operator B can still control, the parameters of their system. And there should be a interconnection, no, of SMO to SMO. Okay, SMO to SMO. Okay, so this is how will be the setup of MORAN, no? MORAN use case, or MORAN or OMON, or an active RAN sharing use case using the Open RAN. So it might be, I don't know, it might be a long shot because we need to have two operators operating at Open RAN. Okay, so that we can define this virtualized function into other operators infrastructure. Okay. Okay, so different. So this is different from traditional RAN architectures. So ORAN can provide a set of open interfaces. Yeah. So remote, E2, okay, and then O1, O2, okay, that can enable monitoring the remote user's performance. Just imagine the functionality. You own the functionality, but it is defined in other companies' infrastructure. That's how they look on the Open RAN of the shared RAN sharing use case. Okay, so in this case, the ORAN introduces a more freedom in the RAN sharing process, because previously when we implement the MOC-N on the MORAN, we cannot get the KPI directly. No? We cannot get access to the OSS of the other operator. So what we do, we just request KPIs from them, and then we try to analyze. No? It's not we don't have an independence, no, when we do the MOC-N, especially if we are the one only we are the one sharing. No? Yeah, we are not the host. Okay. Okay. So in this case, each operator will be enabled to configure the shared network resources independently from configuration and operating strategies of other sharing operators. So this is an opportunity as well sa mga third-party and neutral parties. That, for example, yung mga tower sharing companies, if they will go on tower sharing, they can also provide yung mga equipment on site, right? They can also provide this one open radios, GPP hardware, and ODU, and then ask the operators. You can also rent not only the tower, not only the antenna, but also the radio. Right? So it's a good business in the future if there's a lot of operators working on Open RAN. Okay. So in this case, each operator can configure the shared network resources independently. Not like nung ginagawa namin ngayon, that we ask for for parameter change, we ask for KPI change or KPI extraction. Okay. So you have independence from configuration and operating strategies of other sharing operators. Okay. So there is one use case. If you could just check this link, conducted by Parallel Wireless Network Sharing MOOC-N. So this is, I think it's, I forgot where is this, which area is this. So the Parallel Wireless Network Sharing helps new operator like Mayutel to build 3G and 4G Open RAN network in 3 months. So Parallel Wireless Open RAN controller, so they enable the Mayutel Open RAN network to share Telefonica score. Yeah, so they share with the Telefonica. Okay, so Mayutel is the local operator in this area. Okay. Okay. So I think that's it, no, for my presentation for today. Okay, I hope it's not too heavy, no, sa discussion today. Okay. And do you want to proceed with the quiz or you want to proceed with the Q&A? Let me know. You want to proceed with the quiz or you want to proceed with the Q&A? If you want to proceed with the quiz, you want to test your knowledge, we will be doing Kahoot. So why join the quiz? So you can test your knowledge of the topic. And then if you be the top one, you will win one special access to 5G NR Advanced course in Terahertz Club starting March 25. Okay, 7 p.m. to 9 p.m. Okay, so you want to have a quiz. Okay. Okay, so it's just a mabilis lang tong quiz natin. Okay. This is a disaggregated RAN functionality built in using open interface specification between elements. What do you call this disaggregated RAN functionality? Open interface specification. Yes, Open RAN. Let's see. Who's on the top one? Bry. Let's see how long can Bry sustain. In wireless telecom, the RAN gives mobile network coverage to subscribers. What does RAN mean? What is the meaning of RAN? Radio access network. Okay. What are the two main initiatives that support Open RAN? Yun yung dalawa. Two main initiatives that support Open RAN. First is founded by Meta or Facebook. The other one is an alliance. Yes. So, TIP and ORAN Alliance. Ati Kalam. This group has created its own ecosystem of Open RAN with small cells in mind. Okay, so there is a group. Okay, there is a group that created its own ecosystem of Open RAN, small cells. They are focused only on small cells. That is the Small Cell Forum. Yeah. SCF. Okay. Number 5, true or false? Open RAN enables multi-vendor RAN solutions and provides the freedom to optimize each component of the network. Okay, it's JM. It's number 1. Number 6, it is the component that manages and automates all aspects of RAN orchestration, management, and automation of RAN. Service management and orchestration, the SMO. Number 7, multi-select. Open RAN is an industry movement to develop disaggregated and interoperable radio access network solutions using what? No. Of course, GPP, software-defined, and open interfaces. Number 8, it was formed by Facebook in 2016 and is more deployment and execution focused in terms of the Open RAN ecosystem. So they are doing the plug fest. Telecom Info Project. Number 9, it is the radio access network that uses COTS hardware, open interface, and proprietary software multi-vendor. Open RAN. Number 10, multi-select. Name the 2 BBU functional units in 5G Cloud RAN architecture. Dalawang BBU ba na? Separated BBU. What are those? Distributed and centralized. Number 11, RAN sharing type, where RAN components are shared while core networks remain separate. It uses separate spectrum. Which is it? RAN. Okay. Okay. Number 12. It's a collaboration between the ORAN Alliance and the Linux Foundation with the goal of promoting open source software for RAN. What is that foundation? They are creating software for RAN. For open RAN. Software for open RAN. What do you call that? The ORAN software community. Okay. Number 13. Last 2 questions. It's a RAN architecture where standalone base station has both the BBU and the RU installed at the cell site. Nandun yung BBU at RU sa cell site. Natin ito pala. Okay. Number 14. Choose the 2 types of brick. What are the 2 types of brick? Okay, so near real-time rig and the non-real-time. From Carlo, what is the situation or situation with Oran in your country? So currently, right now, the previous speaker is the think they're the only operator released the result of their POC, proof of concept. That's the status pa lang, Carlo. No deployment yet. It's only on the testing stage. Are the indoor system provided by the telcos at their own cost, or does the building mall owner shares the cost? They are handling the cost, Sir Alberto, of that one. Sir Richard, good morning. In roaming from one antenna coverage to another, do you also calculate the packet data loss? What is the standard acceptable that users will not experience loss of connection? Thank you. It depends on the services, August, and it depends on the technology. It depends on the features that you're activating. Like for example, in some cases like voice, like for example, so that's important, no? Kapag ka nagvo-VoLTE ka, so packet data loss is important kasi magpuputol-putol yan. So it depends yung certain number. We don't have yet wala akong naka-ready yun. Pero it depends sa mga services natin. What is the free software? Is there a free software for the coverage simulation? Yes, you can go for Cloud RF, Carlo. Just check in the Google Cloud RF. You can have the free software. RF planner, you can just go to the website ng wireless planner. Okay, John, you can get this planner. Is it possible for telcos to share on a cell site for more? Yes, RAN sharing. Meron tayong existing RAN sharing ngayon using the typical telco vendors, existing vendors. Sir Richard, in installing multiple cell sites or base station, is there a standard level of radio power that's acceptable, just like in designing multiple APs? Typical sa nominal, so to maximize the coverage, we are using 20 watts in macro and then lower power sa mga micro, sa mga pico sites like 2 watts or up to 50 milliwatts, yung mga pico sila maliliit. So 50 milliwatts, 2 watts, 20 watts, 40 watts. Yan yung mga typical power, August. Will the RAN disaggregation CUDU for 5G GNode B or 5G ORAN? It's 5G GNode B also. Okay. How are network resources provisioned to users and services? What is the impact of quality of service or quality of experience? Like this, Emmanuel, so that everybody can also relate. So like for example, the resources are the frequency or the spectrum, right? So imagine it is a highway. Imagine it's a highway, congested highway, and a lot of vehicles or cars, buses are stranded, congested yung kalsada. And then suddenly, there is an ambulance going to the hospital or for some emergency case. So what will happen, using the quality of service, the QoS, if you have a high quality of service, like for example, voice call has a higher quality of service than the email, which needs some delay, okay? We don't need some delay. So just like the ambulance, what will happen? The resources will be allocated to you. Bubuka yung kalsada, di ba? Tatabi yung mga vehicles so that you can have a way going to the hospital. So yun yung ginagawa na. So they are prioritizing the resources to you. In future po ba pwede na tayo mag-deploy ng portable cell sites? Yes, I think so because there's a portable cell site na hosted by Singtel, which is partner ng Globe. Yeah, meron silang portable cell site. For white box hardware, is the same hardware for ORCU or ODU? Yes, and then sometimes they are combined in one box, the OCU and the ODU. It depends on the implementation or application. What is the difference between load balancing and traffic steering? It's the same. Is it accurate to say that traffic hijacking apart from traffic steering? No. It's the same, no? In traffic steering and traffic balancing. So it's the traffic steering is the term that we are using in the Open RAN. But currently, ito yung traffic balancing na ginagawa natin. Okay, mas intelligent lang yung traffic steering dahil we are using artificial intelligence in doing a decision. Sa traffic balancing, we are using the intelligence ng engineer, no? Pati yung mga features. Like for example, you implement a parameter and then you will observe, right? After observation, observe ng KPI, kapag hindi maganda yung timpla ng parameter, you will just change it again. So it takes time. It takes analysis. But in the traffic steering, it's almost the same principle. But what is happening there, there's an artificial intelligence doing that work instead of the optimization engineer. Do the RIC automation and decision making in changes of network parameters. We'll consider also network parameter. Yes, we call it the enrichment information. Yan. So may KPI tayong ginagamit. Almokhtar. May Cloud RF to simulate antenna design. May Open Run simulator ba? Yeah, that's the one that I would like to point out, no. So just imagine, no, what will happen is that if you try to do simulation, when you try to configure your equipment, like for example, configure equipment, you'll just have to change the equipment here. If it's Open Run, there's a possibility that the simulators will only add the Open Run equipment here and the performance of the radio. Okay, so that would be the changes. In Moran, a scenario where there is operator A and operator B, how will the maintenance responsibility will be handled? Who owns the infrastructure, Edward? So kung sino yung may-ari nung radio, kasi di ba, sino yung nagtayo nun, nakikishare lang ako eh. So if operator A owns the infrastructure, they are responsible for the maintenance. Kasi di naman sila bibigyan ng permit ng iba kung ibang magme-maintain pa nun. Hi sir, does the 3G tech will be possibly removed and will not be available in our country, or 3G will be prereq to deploy 4G and 5G? It depends sa operators assessment kung saan mas mas magiging beneficial para sa subscriber. Okay? Kung ano yung para ano yung frequency ma-free up to give way for the new technology. Yan. So nasa mga operator yan. Does MOC-N and MORAN mean single management system for both network provider? Normally yes, kung sino yung may hawak ng system, sila yung merong management, no, sa provider, sa mga parameters. Like for example, ginagawa dati, humihingi pa kami ng KPI. Hindi kami binibigyan ng access dun sa network management system. That's it for today.